Hello dear students, now we are going to discuss the another accessory organ of digestive system, that is liver. Okay, so in medical term the liver refers to hepatica. Okay, liver is the largest gland in the body, weighing between 1 and 2.3 kg. It is reddish brown in color and highly vascular. The liver, situated in the upper part of the abdominal cavity, occupying the greater part of the right hypochondriac region, part of the epigastric region, and extending into the left hypochondriac region. Okay, so major part of the abdominal cavity is occupied by the liver. Its upper and anterior surfaces are smooth and curved to fit the undersurface of the diaphragm. Okay, so its upper and anterior surfaces are smooth and curved. Why? To fit the undersurface of the diaphragm. Okay, its posterior surface is irregular in outline. Okay, and then the liver is enclosed in a thin elastic capsule and incompletely covered by a layer of peritoneum. Folds of peritoneum form supporting ligaments. Folds of peritoneum form supporting ligaments attaching the liver to the inferior surface of the diaphragm. Okay, so the ligaments giving support and attaching the liver to the inferior surface of the diaphragm. It is held in position partly by these ligaments and partly by the pressure of the organs in the abdominal cavity. Okay, pressure of the organs of the abdominal cavity and the ligaments, peritoneal ligaments, held the liver in position. Okay, clear all of you? So this is the figure of liver. You can see, right, it occupies right hypochondriac region and extends to epigastric region and also extend to left hypochondriac region also. Organs associated with the liver: superiorly and anteriorly, diaphragm and anterior abdominal wall. Inferiorly, there is stomach, bile ducts, duodenum, hepatic flexure of the colon, right kidney and adrenal gland. And posteriorly, esophagus, inferior vena cava, aorta, gallbladder, vertebral column and diaphragm. Laterally, lower lips and diaphragm. All these are all associated organs with the liver. See, there is anterior view and posterior view of the liver. So in anterior view, you can see these two lobes. The anterior surface is smooth. Okay, and posterior, if you see the posterior view, it is having very irregular outline. Okay, in this anterior view, you can see right lobe and left lobe, and you can observe this right lobe is larger than left lobe. Okay, clear? And then this posterior, in posterior view of liver, there are ligaments. Okay, with these ligaments, what ligaments are there? Right triangular ligament, left triangular ligament, falciform ligament, teres ligament. Okay, all these ligaments supporting the liver in position. Okay, and gives attachment to the diaphragm. Let us see the lobes of liver clearly. The liver has 4 lobes. Okay, how many lobes are there in liver? 4 lobes. Yes, very good. The two most obvious are the large right lobe and the smaller. So out of four lobes, 2 lobes are larger and obvious. That means can be seen. Okay, clearly. And larger right lobe. So in these 4, larger right lobe is there and the smaller wedge-shaped left lobe. Okay, the other 2 are the caudate and quadrate lobes. These caudate and quadrate lobes are areas on the posterior surface. Okay. Quadrate lobe, it is seen on the inferior surface of the right lobe, whereas caudate lobe chiefly situated on the posterior surface. Okay. Right and left lobe. Okay. And caudate lobe. You see two smaller lobes, that is caudate lobe and quadrate lobe. Okay. And association. The liver with the other stomach, spleen, pancreas, colon, gallbladder, bile duct, small intestine, etc. Okay, next is the portal fissure. The portal fissure is the important structure you can observe in the liver. Important landmark it is. Okay, let us see what is it. This is the name given to the region on the posterior surface of the liver. So, where the portal fissure, it is the region on the posterior surface of the liver where various structures enter and leave the gland. Okay, various structures enter and leave the gland. That region is known as the portal fissure. Okay, so what are all those leave the gland? What are all those enter the gland? Let us see. The portal vein enters and carrying blood from the stomach, spleen, pancreas and the small and large intestines. Okay, portal vein enters into this region, that is portal fissure. This portal vein carrying blood from the stomach, from the spleen, pancreas and the small and large intestines. And next is the hepatic artery enters carrying arterial blood. It is branched from the celiac artery, which is a branch from the abdominal aorta. So hepatic artery is the branch from the celiac artery. This celiac artery is the branch from the abdominal aorta and it carries arterial blood to the liver. And next, nerve fibers, those are sympathetic and parasympathetic, enter here in this region. And the right and left hepatic ducts, leave and carrying bile from the liver to the gallbladder. That means it is leaving the liver. Okay. Next, lymph vessels leave the liver, draining some lymph to abdominal and some to thoracic nodes. That is portal fissure. Okay. Next, peritoneal folds. There are 4 peritoneal folds are there. That is falciform ligament, coronary ligament, triangular omentum, lesser omentum. Okay, let us see one by one. What is this falciform ligament? Fax means sickle. So, the falciform ligament is sickle-shaped fold of peritoneum stretching from the liver to the diaphragm and anterior abdominal wall. The lower free border of this ligament lodges the ligament teres or the round ligament of liver, which is the remnant of left umbilical vein. Remnant means destroyed. Left umbilical vein. Destroyed. This left umbilical vein is remnant because it is present in fetus. Clear? Next is the coronary ligament. This ligament having upper or anterior and lower or posterior layers. 2 layers. Coronary ligament consisting upper layer and lower layer. These layers stretches between the right lobe of liver and diaphragm. This stretches between right lobe of the liver and diaphragm. And then the anterior or upper layer and the posterior or lower layer fuse laterally, forming the right triangular ligament. Left triangular ligament is a short triangular fold stretching between the left lobe of liver and diaphragm. Okay. Okay, this is right side, this is left side. Okay. This is between left lobe of liver and diaphragm, and then this anterior formed by posterior lower fold laterally forming the right triangular ligament. This light, okay. Next is triangular omentum. Left triangular ligament and right triangular ligaments are there. The left triangular ligament, this is formed from the left layer of the falciform and lower layer of the coronary as they meet at the left. Next, right triangular ligament. This is formed from the two layers of the coronary ligament meeting at the right. Okay, clear? All these are all the peritoneal folds which forms peritoneal ligaments and giving support to the liver to held in position. Clear? Next is lesser omentum. This lesser omentum, where you see, yes, this lesser omentum is a double fold peritoneum, connects the lesser curvature of the stomach to the liver. Okay, in the liver it is attached to the fissure for ligamentum venosum. Okay, this ligamentum venosum, there it is attached, is a fissure with this the lesser omentum attached in the liver. Clear? Next is the blood supply. The hepatic artery and the portal vein take blood to the liver. Okay, hepatic artery and portal vein take blood to the liver or gives blood to the liver, and venous return is by variable numbers of hepatic veins that leave the posterior surface and immediately enter the inferior vena cava just below the diagram. Okay, so venous supply, venous return by this one, hepatic vein. Okay, this hepatic vein enters inferior vena cava just below the diaphragm. Okay, clear? Hepatic artery and hepatic vein. Hepatic artery serves pure blood, whereas venous return drain impure blood through hepatic vein, and this hepatic vein enter or pour its secretion into inferior vena cava. This is hepatic blood flow. You can see through figure. This is center, liver is there. This liver is supplied by the aorta. Okay, aorta, and the hepatic artery is giving pure blood to the liver. Okay, and then the impure blood from the liver is drained out by hepatic vein. This hepatic vein enters into inferior vena cava. Okay, so here you can see from GI tract, hepatic portal vein also enter into the liver, and this hepatic portal vein as well as hepatic artery gives blood supply to the liver. Okay, whereas this hepatic vein takes out impure blood or venous blood from the liver to the inferior vena cava. Okay, clear all of you? Next is the structure or histology of the liver. Okay, so listen carefully. The lobes of liver are made up of tiny functional units called lobules. Okay, the functional units of the liver, lobes of the liver are called lobules. Okay, you have to keep in your mind, lobules are the functional units of liver. And then these liver lobules hexagonal, that means 6 edges will be there, hexagonal outline, and are formed by cubical shaped cells. Okay, in this hexagonal lobule there are cubical shaped cells called hepatocytes. These hepatocytes arranged in pairs of columns radiating from a central vein. Okay, between two pairs of columns of cells are sinusoids. These sinusoids are also known as blood vessels with incomplete walls. Okay, these sinusoids containing a mixture of blood from the tiny branches of the portal vein and hepatic artery. This arrangement allows the arterial blood and portal venous blood to mix and come into close contact with the liver cells. Among the cells lining the sinusoids are hepatic macrophages. Okay, you keep in your mind, this is very important landmark, that is hepatic macrophages are Kupffer cells. The function of these Kupffer cells is to ingest and destroy worn out blood cells and any foreign particles present in the blood flowing through the liver. Okay. The blood drains from the sinusoids into central or centrilobular veins. These central veins join with veins from other lobules, forming larger veins until eventually they become the hepatic veins, which leaves the liver and empty into the inferior vena cava. One of the function of liver is to secrete bile. Function of liver is to secrete bile. It is seen that bile canaliculi run between the columns of liver cell. This means that each column of hepatocytes has a blood sinusoid on one side and bile canaliculi on the other. The canaliculi join up to form larger bile canals until eventually they form the right and left hepatic ducts which drain bile from the liver. Lymphoid tissue and a system of lymph vessels are also present in each lobule. Okay, that is about the structure, and again I will explain this clearly in video. Okay. So see this beautiful figure, see. So here this is the lobule, hexagonal. See, it is hexagonal in shape. That means 6 edges are there. 1, 2, 3, 4, 5, 6. Okay, hexagonal. So within this hexagonal shape of lobule, there are hepatocytes. These hepatocytes are cubical shaped cells. Okay, these cubical shaped cells are known as hepatocytes. Okay, clear? Clear? Okay, so you can see here portal venule or portal vein, portal artery and bile duct. Okay, so this portal arteriole are also hepatic artery. Okay, hepatic artery and hepatic vein and bile duct. These three, portal venule also known as hepatic vein, hepatic vein, hepatic vein, and then artery, hepatic artery and bile duct. These three forms, okay, these three forms portal trade. Okay, so this portal arteriole or hepatic artery is branch of aorta, or is a branch of hepatic artery, gives a supply to this every lobule. Okay, and then this next one is branch of portal vein. Venule is portal vein. Branch of portal venule or portal vein also gives supply to the lobule, each lobule. Okay, so then the portal hepatic artery as hepatic vein or portal vein and portal venule, all these two giving supply to the lobules. Okay, these two pour there, this what is this? Portal venule supplies deoxygenated blood, and portal arteriole or hepatic artery pour pure oxygenated blood into these sinusoids. Okay, what is this? Sinusoids. Sinusoids are blood vessels with incomplete walls. Okay. These sinusoids are present between the columns of hepatocytes. So this snuff color cells are there, no? These snuff color cells are known as hepatocytes. Okay, hepatocytes. See here in this plates of hepatocytes. Okay, this between these columns of these hepatocytes arranged in columns. Okay, that means rows, arranged in rows, pairs of rows, jata jataga వరుసగా ఉంటాయి. these are radiating from the central vein. These columns of hepatocytes radiating from the central vein. Okay, from center to periphery. Okay, clear? So between these hepatocytes, there are sinusoids. Okay, that you have to keep in mind. These sinusoids are supplied with the deoxygenated blood from hepatic vein branch of portal vein, portal vein, and also it is supplied with the hepatic artery. Okay, so it is consisting mixed blood. This mixed blood in sinusoid is going upward and enter into this central vein. Okay, understand all of you. And then next one is Kupffer cells. Next you are seeing here is Kupffer cells. Is it not? These Kupffer cells are Kupffer cells. What is this Kupffer cells means? These Kupffer cells are also known as hepatic macrophages. Okay, these are the cells lining the sinusoids. Okay, sinusoids. The function of the cells which are lining the sinusoids are known as Kupffer cells. Okay, these are all present in sinusoids, and the function of these Kupffer cells are digestion of foreign material and digestion and destruction of this worn out blood cells. Okay, that is important thing. And then you are seeing this central vein. No, all these central and next one you are seeing here is bile canaliculi. So green canal. So this green canal between two hepatocyte columns, there is canaliculi. One canaliculi that is known as bile canaliculi, and one of the function of this hepatocytes is producing bile. This bile, the cells produce these biles into canaliculi, and this canaliculi flows from center to periphery into the bile duct. Okay, clear all of you what I am telling? So clearly you can observe. Okay, whereas sinusoid blood or mixed blood enter from towards the central vein, whereas this bile is secreting from center to periphery into the bile duct. Okay, clear? Okay, that's all about the histology. So see, structure of liver lobule. See, liver is having liver lobule. This liver lobule is hexagonal, and this hexagonal liver lobule consisting central vein, hepatic artery, bile duct and portal vein. Okay, this portal vein, bile duct and hepatic artery combinedly known as hepatic trade. Okay, so what is hepatic trade? Hepatic trade is the union of three, that is portal vein, bile duct and hepatic artery. Okay, clear all of you? Once again you say hepatic trade is formed by, yes, portal vein, bile duct, hepatic artery. Clear? And you can see this picture, blood flow. So from portal vein and from hepatic artery, these two gives blood supply to the sinusoid. This blood enter into the sinusoid. Okay, and from portal vein, inferiolobular vein and sinusoid. From this sinusoid, blood is entered into central vein. From all the central veins together form hepatic vein. Okay, from this hepatic vein, the blood drain into inferior vena cava. This inferior vena cava enters into right atrium of the heart. Okay, clear? That is the blood flow in the liver and blood flow after leaving the liver. Okay. Let us see functions of liver. So, the liver is an extremely active organ. The functions are, see one by one. First function, carbohydrate metabolism. Okay, so how this carbohydrate metabolism taken place? The liver has an important role in maintaining plasma glucose levels. Okay, first function is maintaining plasma glucose level. Okay, as a function of carbohydrate metabolism. After taken meals, the blood glucose level rises. So at that moment, extra glucose is converted to glycogen for storage under the influence of hormone insulin. Okay. Later, when glucose levels fall, the hormone glucagon stimulates and conversion of glycogen into glucose again, keeping levels within the normal range. So, two hormones, glucagon and insulin. Okay, by using these two, the carbohydrate metabolism or glucose levels will be maintained. Okay, next is fat metabolism. Stored fat can be converted to form triglycerides, fatty acids, which can be used by the tissue to provide energy. Next is the protein metabolism, deamination of amino acids. Okay, in protein metabolism, through two processes will be done by the liver. One is deamination and second one is transamination. In deamination, it removes the nitrogenous portion from the amino acid, which is not required for formation of new protein. Urea is formed from the nitrogenous portion, which is excreted in urine. Okay, urea is formed. This urea excreted in urine. Okay, and breaks down nucleic acid to form uric acid, which is excreted in the urine. So, after protein metabolism, uric acid is excreted and as well as excreted in the uric acid formed and excreted in the urine, and then urea is formed from the nitrogenous portion, which is urea and uric acid excreted in the urine. And next is transamination. In this transamination, it removes the nitrogenous portion of amino acid and attach it to other carbohydrate molecules, forming new non-essential amino acid. That is the transamination. Okay, in transamination, it removes nitrogenous portion of amino acid and attach it to other carbohydrate molecules, forming new non-essential amino acid. Next function, synthesis of plasma proteins and most blood clotting factors from amino acids. Synthesis of plasma proteins and most blood clotting factors from amino acids. Okay. And next function, breakdown of erythrocytes and defense against microbes. So, breakdown of erythrocytes and defense against microbes are carried out by the special cells, that is Kupffer cells in the sinusoids. Okay, already we discussed. Next is the detoxification of drugs, noxious substances. These includes ethanol and toxins produced by microbes. Okay, microbes. This function is very important. And inactivation of hormones. These include insulin, glucagon, cortisol, aldosterone, thyroid, and sex hormones are inactivated in the inactive form in the liver. Okay. And production of heat. The liver uses a considerable amount of energy and has high metabolic rate and produce a greater deal of heat. It is the main heat production organ of the body. And secretion of bile. The hepatocytes synthesize the constituents of bile from the mixed arterial and venous blood in the sinusoid. These include bile salts, bile pigments, and cholesterol. Okay, bile consists bile salts, bile pigments, and cholesterol. And next last function is storage function. The substances stored in the liver are glycogen, fat-soluble vitamins A, D, E, K, iron, copper, and some water-soluble vitamins, that is vitamin B12. All these are all stored in the liver. Okay, all these are all the functions of liver. And next, let us see composition of bile. About 500 ml of bile are secreted by the liver daily. 500 ml of bile. Okay, this bile consists of water, mineral salts, mucus, bile pigments, mainly bilirubin, bile salts, which are derived from the primary bile acid, cholic acid, and chenodeoxycholic acid. Okay, all these are all the acids. And cholesterol. Okay, let us see how these will be formed. Okay, the bile acids. Bile acids are cholic and chenodeoxycholic acids. These are all bile acids. These are synthesized by hepatocytes from cholesterol and conjugated with either glycine or taurine and then secreted into bile as sodium or potassium salts. These acids conjugate with glycine or taurine and then form sodium or potassium salts. Okay. In the small intestine, they emulsify fats, aiding their digestion. Okay. And in the terminal ileum, most of the bile salts are reabsorbed and returned to the liver in the portal vein. This enterohepatic circulation or recycling of bile salts ensured that large amount of bile salts enter the small intestine daily from a relatively small bile acid pool. Bilirubin is one of the products of hemolysis of erythrocytes by hepatic macrophages in the liver and by other macrophages in the spleen and bone marrow. So bilirubin is also one of the product of hemolysis. Hemolysis will be taken place in the liver, no? So because of that hemolysis, bilirubin will be produced. Okay. Okay. And hepatic macrophages in the liver and by other macrophages in the spleen and bone marrow. Okay. In its original form, bilirubin is insoluble in water and is carried in the blood bound to the albumin. In hepatocytes, it is conjugated with the glucuronic acid and becomes water soluble before being excreted in bile. Bacteria in the intestine changes the form of bilirubin and most is excreted as stercobilin. So in the large intestine, I told you the bilirubin, the function of large intestine is forming this stercobilin, is it not? So bacteria in the intestine change the form of bilirubin, which is secreted from the liver into the duodenum and large intestine. There the bilirubin excreted as by synthesis of bacteria in the large intestine, it is excreted as stercobilin in the feces. A small amount is reabsorbed and excreted in the urine as urobilinogen. Jaundice is a yellow pigmentation of the tissues seen in the skin and conjunctiva caused by excess blood bilirubin. Okay, that's all about. See here, spleen. Hemoglobin from worn out erythrolysis or killing destruction of erythrocytes will be taken place. So because of this, heme and globin will be formed. From heme bilirubin will be formed, released. This bilirubin from the spleen enters into liver and this bilirubin through bile duct enter into intestine, and in intestine it is by bacteria it is synthesized as a stercobilin will be formed through process excreted through feces, and some of this is reabsorbed and enter into kidney, and there in the kidney it is excreted in the form of urobilinogen. Okay, and extra bilirubin which is present enter into this liver again through this portal vein. Okay, clear? That's all about liver. So in this session we completed regarding anatomy and physiology of the liver. In this we came to know what is this liver and where is the liver situated and what are all the lobes it is consisting and what are the ligaments supporting the position of liver and what is the histology of liver, and then functions of liver, and what is the bile, and what is the functions of bile. Okay, clear all of you? That's all about liver. Okay, students, if you have any doubts, you please call me and find out, clarify your doubts. Okay, thank you.